Okay, so in the previous video, we talked about a scientist, Wollaston, that basically led into this whole theory of atomic absorption and atomic emission. But he really didn't take matters into his own hands and really explain what he was seeing. He just reported what he was seeing, and that was it. And we said that in the continuous spectrum, the Roy G. Biv colors, there are areas that basically are dark. And these dark lines have been given a name over time. And these dark lines are called the Fraunhofer lines. So whenever we see one of those, that is the term that we give it. Now, the reason is because Fraunhofer was basically a scientist that led into the explanation and discovery of why these dark lines are present. So he took Wollaston's work and actually explained what was going on and just didn't report what was going on. So this happened in the early 1800s. All right, we're looking at 1810, 1820, somewhere in there. Honestly, I think the actual exact date is 1817 when it was reported, but of course, this took a little bit of time and effort to develop, not just 1 year on one day magically. Bing! I know now why the dark lines are there. All right, so 1817 is the date that's given credit to the majority of Fraunhofer's work. Now, in total, Mr. Fraunhofer recorded and reported around 570 dark lines. 570 of these. Within the area of Roy G. Biv, 570 dark lines that should have been there, but they were not. Now, today, thousands are known. I think the actual previous total that I have seen is that we have discovered more than 25,000 lines that are dark, that should be there, that are not there for a number of different reasons. But during the time of Fraunhofer, 570 was a significant number, at least to start off in the world of atomic absorption and atomic emission. Now, some of these lines, Fraunhofer said, were very dominant. They were kind of a go-to line, a very quick way, almost like if you had the alphabet and encyclopedias up. The encyclopedias would maybe be broken down into A, B, C, D, E, F, G, right? So Fraunhofer took these 570 lines and said, well, there's some of these that are very major. And like an encyclopedia, I'm going to start organizing them in points of reference so it's very easy for me to find the information that I need to find. So he labeled these very dominant lines with letters, and these letters were A through K. A, B, C, D, E, F, G, H, I, J, K. Those were dominant Fraunhofer lines during the time of discovery. So, for example, red is kind of the way we always start off the rainbow, right? So the red he gave with the letter of A. And anytime that he was working maybe in that area, well, A was a very quick dominant line, and it was a very quick point of reference for him, and he could go to that area and then make more discoveries within the red region before moving on to a different color or another set of colors that he wanted to study. This is actually how sodium D became about. Sometimes you'll often hear people in a laboratory talk about the sodium D lamp or the sodium D line. And the reason that the D is there is because it's point of reference to Fraunhofer. This was a letter designation that he gave into the orange color. And sodium was associated with a very orange, bright flame. And this was the point of reference that Fraunhofer gave it, the D area. So he could go to the D area of the spectrum color wheel, maybe, and start looking at more details within that region. The sodium D lamp is actually used in a piece of instrumentation in our laboratory, and the sodium D lamp, I'm going to let you discover what that was used for. So there is an instrument. It uses a sodium D, and I'm going to say there's at least two. And it uses a sodium D lamp in order to do its job. Can you name them? Now, if you're one of our students, that will probably show up on a test. However, if you're a Chemtechathon student, then we're probably not going to ask you about this because you're only focused on the AAEE world, and maybe you have not been exposed to this other equipment like our students have. All right, so Fraunhofer also was part of astrology. He loved the stars, and he actually reported that, well, there's got to be a reason here. When I take a look at Venus, this looks very similar to the sun. The light that Venus is giving off, or that I see, is the same type of light that the sun is giving off that I can see and record. However, there is a star, a major star called Sirius, and this was different. It wasn't like Venus and the sunlight. It was something totally different that had its own characteristics, and Fraunhofer really wanted to know why. So again, like most people, very early on in the discoveries of these chemical instruments, were not really led by chemists at all. Fraunhofer was labeled as a physicist. I wouldn't necessarily call him an astronomer, but he did look up in the stars for a lot of his answers. Uh, Very early on in his life, he was basically brought into a institution, if you wanted to call it that, and was basically made to work with no pay. And what he was brought into was focused on the discovery and improving telescopes. So now you can kind of put the pictures together. He was working on telescopes on a daily basis. How can we improve them? How can we make them better? Telescopes really play a large part in glass. What kind of lenses are you using in the telescopes? Well, if he could improve the quality of the glass and if he could make the glass better and a little more precise, then he was able to look at the sun and look at Venus and say, well, these two are similar, but the light from Sirius is different because I'm constantly, on a daily basis, working to make this process better for us. He became a master at glass making. No one could touch Fraunhofer in that field. Glass was his forte. He worked with it every day. Finally, he was allowed to not work for the institution anymore and actually get paid for his services, and he became the director of the Optical Institute in England. So he finally was able to be paid for his hard work. The problem is Mr. Fraunhofer died at the age of 39. Very young when he passed away. The problem is that he worked with glass every day. And of course, during this time, certain hazards were not known, at least that we know today. And because he was working with glass, glass making and glass improvement required heavy metals. Heavy metals like mercury. And this process killed Fraunhofer. So it's kind of a sad story. This is what he enjoyed doing. This is what he was a master of. No one was able to beat Fraunhofer in the world of glassmaking. He improved telescopes. He improved those lenses. He talked about these lines that basically were disappearing in the continuous spectrum. And he began to talk about why they were not there. But at 39 years old, what gave him so much credit and what would put him into the history books ends up killing him. 39. There was no record of him ever marrying. There was no record of him having any children. Of course, he is somewhat younger at 39 years old, but there is no record of it ever have happened. And they also give Fraunhofer a mark to say he is the father of stellar spectroscopy. Stellar meaning the universe. All right. So let's take a look at Mr. Fraunhofer. Here's Mr. Fraunhofer. So ladies, ha ha ha, here's your good one. You can take this one home to your mommy and daddy, and guys, maybe for you too, who knows? But this is Mr. Fraunhofer. And the reason that I'm saying that is because this is a somewhat of a change. A lot of times when you take a look at people who were heavily involved in chemistry or laboratory or science related, a lot of times the pictures that you see of them are very old and cranky looking and probably beardy. If you saw them on a street today, you would be like, I'm not talking to that person because he looks a little scary. But Fraunhofer, because all of his things were basically discovered at a very early age, he is very what I would call a breath of fresh air. So this portrait of Fraunhofer looks nothing like some of the other chemists or other scientists in the day that were making these types of discoveries. So, in other words, he was very ahead of his time. But there you go. Not too bad. I think your mom and dad would be proud if you brought him to the Thanksgiving table and set him down to have some turkey and let him talk about all of the discoveries of the universe that he's made. So there you go. There's Mr. Joseph Ritter von Fraunhofer, 1787 to 1826. All right. So um, after Fraunhofer, we're going to get two other guys that eventually will come up and take Fraunhofer's idea and expand it even more so. And these two scientists' name is Kirchhoff and Bunsen. Yes, Bunsen as in Bunsen burner. So in the next video, we're going to talk about what they did to expand this whole information and really set the atomic absorption and atomic emission discovery on fire. So in the next video, this is where we're picking up, and we'll talk about two more scientists, maybe not as young and as attractive as Fraunhofer, but they at least made some discoveries. So we'll show you some pictures of them if you're interested.